Hello everyone. Myself, Professor Jalpa Shah, Assistant Professor in Computer Engineering Department, Aditya Silvarok Institute of Technology, Silvarok University. Today we are going to see the topic known as bubble shot of the subject, that is the analysis and design of algorithms. In short, it is known as ADA for the fifth semester as a part of the curriculum of the BTech program. So now let's start. So the outline, that is, first we will understand, as this is a basic short, first we will understand that what do you mean by the shorting algorithms, and then we will see in a detail of the bubble short, so that we will see the example first, then we will see the algorithm, then we will see the analysis, and lastly we will see the how C program can be written using the bubble shot. So it is the practical approach that we will see using Turbo C software. So learning objectives of today's presentation, of today's lecture, is interpret the code for the bubble shot, trace the code for the bubble shot algorithm with input data, identify factors that could influence the efficiency of a bubble shot implementation, to be able to explain and implement the bubble shot using C. So now let us first see that what do you mean by shorting algorithms. We all know that shorting means arranging the elements in the increasing order or the decreasing order. It can be done on numbers, characters, strings, or the employee ID, etc. So the sorting algorithms are classified as internal sorting and external sorting. So now we will see that what do you mean by internal sorting. So internal sorting can be done using or can be done on the reasonable amount of data and carried out on the main memory. Whereas external sorting run on huge amount of data and carried out on main memory along with the secondary memory. So here, if we have the small amount of data, or we can say the reasonable amount of data, then we can apply the internal sorting, and it is only carried out on the main memory. Whereas external sorting will be used when there is a huge amount of data to be sort, and it can be because it is a huge amount of data, so it requires main memory along with the secondary memory, which is known as the external sorting. Now we will start with the bubble shot. So first we will understand that what do you mean by the bubble shot. So here we can say that it is the simplest algorithm because it is the very basic sorting algorithm and it is very easy to implement. So it is known as the very simple algorithm. In this, largest element is moved at the highest index in the array. As the largest element moves to the highest index position, it is called that element is bubbled up from its position. Hence is the name known as bubble shot. That means whenever we will do the pass structure, here I have already written that it works on a pass structure. We will see in a detail that what do you mean by pass when we will see the example. So your large element will be bubbled up from its position and it will be moved to the highest position into the array. So in every pass, next last element will occupy its position. So now let's start with the example of the bubble sort. So array elements given to us to sort the data, that is 70, 30, 20, 50, 60, 10, 40. So we are given that we have to sort the given elements using the bubble sort. So let's start. So as I told you that bubble sort works on a pass structure. Pass, that means one pass, that means we have to start with the first element, and from comparison we need to reach to the last element. So starting with the first element and reaching or ending to the last element will be considered as a one pass. So in every pass, inner comparison will be done between the elements. So first two elements will be compared, that is 70 and 30. And if the second element is lesser, it will be swapped with the second element. So here you can see that the second element is lesser. So that why it is swapped with the first one. So 30 and 70 will be swapped. Now, after swapping, if it is swapping is required, it will swap the elements and then it will compare with the next element. So now position 1 and 2 will be compared. So 70 and 20 will be compared. So again, 20 is lesser value. So we can say that the second value is lesser. So again, it will be swapped with the data. So 20 and 70 will be swapped. And now the comparison will be done with 70 and 50. That is the second and third position of the array. Again, we can see that 50 is lesser than 70. So again, swapping will be performed. So 50 and 70 will be swapped with each other. Now, comparison will be done between 70 and 60, which is the positions of the array, that is third and the fourth one. Again, here we can see that 60 is lesser than 70. That is the second value is lesser than 70. First value. So 60 and 70 will be swapped with each other. Again, now comparison will be done with 70 and 10. That is the array position of fourth and fifth. Again, here we can see that 10 is the lesser value, which is the second value, than the first value, that is the 70. So again, swapping will be performed, that is 10 and 70 will be swapped with each other. So now it will be compared with the last element and the last to second element. So that is 70 and 40. Again, 40 is lesser than 70, so it will be swapped. So here you can see that we have reached to the last element of the array. So we have completed our pass 1. So you can see that at the end of pass 1, highest element has occupied its position. So 70 is the highest element in the given array. So which should be last. So it has occupied its position. Now, the output of the first pass will be goes as an input to the second pass. So here the output of the pass 1 is 30, 20, 50, 60, 10, 40 and 70. So that will be considered as the input of the pass 2. So 30, 20, 50, 60, 10, 40, 70. So now the same process that we have done in pass 2, we have to do pass 1 that we have to do in a pass 2. So starting with the first element, we have to end to the last element. So first and second element will be compared. Again, you can see that 20 is lesser than 30. So it will be swapped with each other. So 20 will come first and 30 will go to second. Now, first and second position elements will be compared, 30 and 50. But here you can see that 50, that is the second value, which is greater than the first value. So no swapping will be performed. It will just skip the step. So again, it will start the comparison for the second and third position elements, that is 50 and 60. Again, second element is greater, so no swapping will be performed. It will skip that and it will continue to compare. So now third and fourth position will be compared, that is 60 and 10. So 10 is lesser, which is the second value. So here swapping will perform. So 10 will come first and 60 will go second. Now the 60 and 40 will be compared. So again, you can see that are the fourth and fifth position of the array. So 40 is lesser. So again, swapping will be performed and 40 and 60 will occupy its position. Now 60 and 70 will be compared and 70 is greater value. So there is no swapping will be performed. So it will remain as it is. And as you see that we have reached to the last element of the array. So after completing the pass 2, you can see here that the last to second element has occupied its position. So here you can see that at the end of pass 2, two elements of the array has occupied their position. So again, output of pass 2 will be goes as an input to the pass 3. So that is 20, 30, 50, 10, 40, 60, 70. As we have done in pass 1 and pass 1 and 2, same process that we have to follow in pass 3. So 20 and 30 will be compared. 30 is greater, so no swapping. Again, 30 and 50 will be compared. 50 is greater, so no swapping. 50 and 10 will be compared. But here you can see that 10 is the lesser value, so it will be swapped. So 10 and 50 will be swapped. Again, 50 and 40 will be compared. Here also 40 is lesser value, which is the second value. So 40 and 50 will be swapped with each other. Again, 50 and 60 will be compared. Again, 60 is greater value, so no swapping will perform. Same with 60 and 70. 70 is greater, so no swapping will perform. We have reached to the last element of the array. So at the end of this, you can see that last 3 elements has occupied its position. But here you can see that 40 has also occupied its position. Now the output of pass 3 will goes to the input as pass 4, that is 20, 30, 10, 40, 50, 60, 70. So now again the same process, that is 20 and 30 will be compared. Second value is greater, so no swapping will perform. 30 and 10 will be compared. Here second value is lesser, so swapping will perform. 30, 40 will be compared, no swapping. 40 and 50 will be compared, no swapping. 50 and 60 will be compared, no swapping. 60 and 70 will be compared, no swapping. So here you can say that 30, 40, 50, 60, 70 has occupied their position. Now pass 5. So in output of the pass 4 will goes as an input to the pass 5. That is 20, 10, 30, 40, 50, 60, 70. So starting with the first element, 20 and 10 will be compared. So 10 is lesser value, so it will be swapped. Again, comparison will be done between 20 and 30, no swapping. 30 and 40, no swapping. 40 and 50, no swapping. 50, 60, no swapping. 60, 70, no swapping. So here you can see that at the end of pass 5, array is shorted. That means always the number of passes required to solve the bubble sort, that will be n minus 1. Now bubble sort algorithm, that we need to see, that we have seen the example. Now we need to convert that bubble sort example into the algorithm. So it will be started as algorithm bubble a of 0 to n minus 1. Problem description, that is, this algorithm is for sorting the elements using bubble sort. Input an array of elements a of 0 to n minus 1, that is to be sorted. Output the sorted array a of 0 to n minus 1. Now we have seen that our pass structure, if there are 7 elements, our passes are 5, so that is n minus 2. So we can consider the for loop, that is I is equals to 0 to n minus 2 do, and our element comparisons are dependent onto the passes. So we have to minus the number of passes values. So second for loop will be for j, that is j equal to 0 to n minus 2 minus I. And in that we have to compare the inner elements. So that is, if a of j is greater than a of j plus 1, then we have to do the swapping. That means if the first element is greater, then we have to do the swapping. That is, temporary is equals to a of j. A of j is equals to a of j plus 1. A of j plus 1 is equals to temporary. So this is the algorithm for the bubble sort. Now on the base of algorithm, we can solve the analysis or we can find out the efficiency or the complexity of the algorithm. So here you can see that this is the outer loop which is used for the pass, and this is the inner loop that is for the comparison of the elements. So now on the base of the algorithm, we will do the analysis. So in this algorithm, basic operation is comparison. So we can obtain the sum as follows. That is C of n is equals to outer for loop with variable I, inner for loop with variable j, and the basic operations to require the output. So C of n is equals to first inner outer loop, that is I equal to 0 to n minus 2. Inner loop is j equal to 0 to n minus 2 minus I, and every time operation will executed once only. So if I remove the limit, so here it is j equal to 0, so no limit on I, so we can consider that into the loop. So that is sigma I equal to 0 to n minus 2, that is n minus 2 minus 1 minus I. Now how that comes? So we have one formula in the mathematics, that is sigma of I equal to 0 to n 1, then that is upper limit minus lower limit plus inner part. So same way, that is upper limit, that is n minus 2 minus I minus 0, that is lower limit plus 1. So if I solve that, I will get that is n minus 1 minus I. Now, to simplify that sum, we will get sigma I equal to 0 to n minus 2 in bracket n minus 1 minus I. So here we have to apply the limit on I, so we can separate it out. So we have separated that into two parts, that is sigma I equal to 0 to n minus 2, n minus 1 minus sigma I equal to 0 to n minus 2, I. So now, so that is equals to, here again, you can see here, that is upper limit, that is if the inner part is I, then it will apply a series. So here upper limit is n minus 2. So in this equation, if we put n is n minus 2, then n minus 2, n minus 2 plus 1, that is equals to n minus 1 divided by 2. So now we have to put that. So sigma of n I equal to 0 to n minus 2, n minus 1 minus n minus 2, n minus 1 by 2. Now, here you can see that is here no limit is given. So again, there is no limit on I, so that we can consider as 1. So upper limit minus lower limit plus inner part. So that is equals to n minus 1 into n minus 1. And here we already got n minus 2 minus n minus 1 divided by 2. Now to solve this, n minus 1 will be common from both, that is 2n minus 2 minus n plus 2 divided by 2. So that is equals to n into n minus 1 divided by 2. So T of n is equals to theta of n square. That is the time complexity of the bubble sort, because we know that the highest polynomial degree is considered as the complexity. So if I remove the brackets, I get n square by 2 minus n by 2. So highest polynomial degree is 2. So theta of n square is the time complexity of the bubble sort. Now let's see the C program to solve the code of the program. So let's search the Turbo C software all of you have. So you can do the program in the Turbo C, or online compilers are also available. So here you can see that you have to start with the code, that is hash. Okay. So we will do that into the online C compiler. So that will be very much easier for, I have shown you the Turbo C. So here I have used one online C compiler. So let's start with the code. That is, has include stdio.h, that is the header file. That is a standard input output header file. Then here it is an online compiler. So second header file is not required for the console. But if you are using a Turbo C, the header file is required, that is has include conio.h, which is console input output. Now void main. Now first of all you have to declare the variables. So that is integer. I is required as for loop is given for I. For j, temporary variable, number of elements, and the last one is the array of size 20. Now we have to take the elements from the user, that how many elements he or she wants to enter. So printf, enter the number of elements. Then scanf %d, comma, ampersand n. So that we will take from the user. Now after taking the how many number of elements that we need to enter, we have to take the elements value from the user. So to take the array elements from the user, we need a for loop. So that is equals to I equal to 0, I less than n, I plus plus. So now we have to take the elements from the user. So scanf %d, scanf %d, comma, ampersand a of I. So after taking all the elements from the user, we need to start the sorting. So as we have seen that for solving the bubble sort, we require two for loops. So starting with the outer for loop, that is for I equal to 0, I less than n minus 2, or you can write less than or equal to n minus, or less than 1, or if you are writing less than or equal to, then you can consider n minus 2. So I plus plus. Now we have to consider the inner for loop. So that is it for j. So j equal to 0. J is less than n minus 1 minus I. If you are writing less than or equal to, then you can write n minus 2 minus I. J plus plus. So that is the inner for loop. Now in inner for loop, we have to do the comparison of the array elements. So that is if a of j is greater than a of j plus 1, then we need to do the swapping as we have seen. So that is a of j is equals to temp, a of j plus 1 is equals to a of j, and temp equal to a of j plus 1. Or here you need to write down a of j is equals to a of j plus 1. So now, after solving all these values or after do the swapping, you need to, here bracket is required. So now we need to display the array elements. So here before this also we forgot to print some message, that is enter the element. So by that user can knows that what it has or he or she has to enter. Now lastly, printf sorted elements. So we need to print the elements that are sorted using the for loop. So that is I equal to 0, I less than n, I plus plus, in which I have to print. So I need to use a function that is printf %d, slash and we are writing, so it will give all the elements into the next line, comma, A of I. Semicolon is required. So that's it. That's the program that we have written. Now, if I run the code, it will ask me that how many elements I need to enter. For example, if I am entering 5, so it will ask me the elements. So I am entering 60, 40, 70, 20, and 10. So we are not getting the answer. So shorted elements are 0. So how you can solve this using the example? That is, here you can see that we have written the array elements, that is A of I. So here you can see the code, that is temporary is equals to A of j is equals to A of j plus 1. And here that is wrong, that is A of j plus 1. So that's why we are not getting output. Now let's again run the code. Instead of that, here I have to write down, that is A of j plus 1 is equals to 10. So again, I need to run the code. Again, I am entering value 5, that is 60, 40, 70, 20, 10. Again, the garbage value that we are getting. So now let's do that with the help of an n minus 1 minus I. Here, so again comparison is done. A of j is equals to 10. Okay, let's copy this code and let's put the same code that over here. Okay, let's copy this code. Okay, here I cannot write get ch as this is online compiler. Same way, I don't have to use CLR SCR function. Same way, I don't have to use the header file, that is ponyo.h. So now run the code, enter the number of elements. Suppose for example 5, I am entering 60, 40, 20, 10, 70. So here I think so there is the issue of the compiler. So I don't need to save this code. So I can say that let's copy this code into the another online compiler so that we can understand it easily. So here let's see the tutorial. Okay, GDB online compiler is also good. So same way, if I copy the code over here, I am running the code. You can see the output. So that is 5, 60, 40, 20, 10, 30. So here you can see that we are getting our output data is shorted. Let's increase me this screen. So here you have seen that there are some problems also with the online compilers. So here this code is working properly. So here we have done with our program. So here today we have seen the algorithms of Bubbleshot, in which we have seen firstly the example, then the algorithm, then the analysis and the C program. So we have complete seen the Bubbleshot. Thank you everyone for the concentration. So let's end the